So I want to review a little bit with you before we practice drawing some Lewis structures. Whenever you draw in Lewis structures, you're representing the covalent bonding that occurs between atoms. And the first thing you have to do is get out your periodic table, and you're going to remember that to find the valence electrons, you look at the group number for the elements. You're going to add up the valence electrons for all atoms in the compound. Then next, you're going to use a pair of electrons, which is a dashed line, to form a bond between each pair of bound atoms, and then arrange the remaining electrons around each atom to satisfy the duet rule for hydrogen and the octet rule for all other elements. And there are some atoms that are going to share more than one pair of electrons when you have multiple bonds, and specifically that normally occurs with carbon, oxygen, and nitrogen. So I just remember like con. They spell con. And they have multiple bonds. Those are common elements that will be seen with multiple bonds. Now, in the last video lesson, I was in the middle of the water molecule, so I'm going to pick back up with that one. So if you're going to draw the Lewis structure for water, you're going to add up the valence electrons. Remember, there are two hydrogens here, so two hydrogens. Each hydrogen has one valence electron. Remember, they're in group 1A. And then there's one oxygen, and he's in group 6A, so he has 6 valence electrons. So that gives you 2 plus 6, which is a total of 8 valence electrons that are going to be used for bonding. Also notice that I underlined the oxygen for you. Oxygen is going to be your central atom, so draw that down first, and then you're going to connect two hydrogens to that. Keep your molecules symmetrical, so I always go on the left side and the right side, and there's my dashed lines. Remember, the dashed lines represent 2 electrons being shared. So right now, 4 electrons have been placed in my structure. So 8 minus 4 leaves me with 4 electrons that I still have to place. Now remember, hydrogen follows the duet rule. So hydrogen already has his 2 electrons here that he's sharing. So this hydrogen has his duet, and so does this hydrogen. So both hydrogens are happy. They're satisfied with their rule. But oxygen only has 4 electrons around him. So we're going to put the remaining electrons around the oxygen. Remember, the dots represent unshared electrons, are called lone pairs, so 2 here and 2 here. That gives you 2, 4, 6, 8 around the oxygen, 2 for each hydrogen. So this is your Lewis structure for the water. The next molecule that I gave you was the cyanide ion. So let's add up the valence electrons for the cyanide ion. And this is a polyatomic ion. So as we did before, there's one carbon, and he's in group 4A, so he has 4 valence electrons. And there's one nitrogen, and he's in group 5A, so he has 5 valence electrons. Now remember, a -1 charge means that it has gained an electron, and we are adding up the valence electrons here because they're the ones that participate in bonding. So when we add it, we're going to have to add one more electron to account for that charge. That gives us a total of 10 electrons. Now remember, at any time you can pause the video if I'm going a little too fast, you can pause the video and then resume it when you're ready. But there's 10 valence electrons here, and I get those by looking at the group numbers. 4A, 5A, and then a -1 charge means he's gained an electron. Now there's no central atom here, so you're going to just connect the carbon to the nitrogen with a pair of electrons, a dashed line. That's 2 electrons that I've used. I connected them with 2 electrons. So come back up here and subtract. That means I have 8 electrons I still have to use. Now, the next thing you're going to do is you're going to place the remaining electrons around the atoms until the octet rule is satisfied. Since we don't have hydrogen, we know that both of these have to have the octet rule. So I'm going to start with the carbon, and I just kind of work my way around, and I put them in twos. 2, 4, 6, 8, 10. Oops, sorry, put too many. Let me go back. I'm going to start that part over, y'all. Let me come back here. I'm going to start putting my dots out. I got a little carried away with that. So let me start over with my distributing my electrons. So we have 8 electrons, not the 10 that I've put out. So 2, 4, 6, 8. So once you've distributed your electrons that you had remaining, which were 8, you then go back and double check for the octet rule. Now notice what I've done is I made sure I did not leave carbon until he was satisfied. 2, 4, 6, 8 are around that carbon, so carbon is happy. He has his octet rule satisfied. However, nitrogen only has 2, 4 electrons, and he must have 8 before you're done or the molecule's not stable. Remember we talked about electronegativity. And electronegativity is the atom's ability to pull on electrons. And so what's going to happen here is nitrogen is pulling on these lone pairs that carbon has. And he's going to make carbon share with them because everybody has to have 8 before they're stable. So these are called lone pairs. It's kind of like if you go to the bank and take out a loan, you're borrowing. It's actually spelled differently. It's spelled L-O-N-E pairs, but it sounds the same. So nitrogen has 4, he needs 4 more. So you're going to take these 2 and you're going to swing them down, and you're going to take these 2 and you're going to swing them up. So what you're going to end up with is a structure that looks like this. You're going to have a triple bond in between the carbon and nitrogen, and these stay on the carbon as 2 dots, and then the nitrogen keeps his 2 dots. And it doesn't matter what side of the nitrogen you put it on. I'm going to keep mine symmetrical. But notice 2, 4, 6, 8, 10 electrons have been used, and that's all we had to begin with. And carbon has 2, 4, 6, 8, and nitrogen also has 2, 4, 6, 8. The only thing you have to do special with the polyatomic ion is put the brackets around it and put the charge as a superscript. All right. The next one is phosphoric acid. Now this is an oxy acid. And so what you got to remember with an oxy acid is that the hydrogens must go, they must attach to an oxygen. So we're going to add up our electrons the same as before, H3PO4. Hydrogen, there's 3 of them, and they have 1 valence electron apiece because they're in group 1A. There's 1 phosphorus, he's in group 5A, so he has 5 valence electrons. And there's 4 oxygens, and they're in group 6A, so they have 6 valence electrons. That gives me 3 plus 5 plus 24. And if you add those together, you do get 32 total electrons. Now, the phosphorus is your central atom, so draw it first. And you're going to attach the 4 oxygens to it, 1 on each of the 4 sides. Oxygen, 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 oxygen. We have used 2, 4, 6, 8 electrons so far. But don't forget you have 3 hydrogens to attach. So distribute the hydrogens, 1 to each oxygen available, until you run out of hydrogens. So now I put my 3 hydrogens out. So all atoms are connected with a dashed line, which is 2 electrons per dashed line. So 2, 4, 6, 8, 10, 12, 14 electrons. So say 32 minus 14, and 32 minus 14 leaves you with 18 electrons you still have to place. So let's take a look and see who still needs electrons. Hydrogen has 2, hydrogen has 2, and hydrogen has 2. So they all have their duet of electrons. The next thing you've got, sorry y'all, I did not mean to connect that. Having a little technical difficulty here. So the next thing you've got to do is you've got to, when you add up your electrons, hydrogens each have 2. That's their duet rule has been satisfied there. And my pen tools are messing up. So oxygens now have 2, 4. That one's got 2. This one's got 4, and this one's got 4. The phosphorus has already 2, 4, 6, 8. So the phosphorus has all 8 that he needs. So the phosphorus is happy, and the hydrogens are happy, but the oxygens are not. So we're going to take the remaining 18 electrons, and we're going to place them until all the oxygens have 8. So 2, 4, that finishes him. 6, 8, 10, 12, 14, 16, 18. That's all 18. Now, every oxygen has their octet, so you are finished with phosphoric acid. The last one we're going to do is NH3, which is ammonia. So we're going to add up our electrons again, NH3. And Nitrogen has 5 because he's in group 5A, and there's 3 hydrogens. They have 1 apiece. That gives you 5 plus 3, which is 8 electrons.